One step here can end your life. This video is about scale distortion. The most lethal places on Earth are not vast regions. They're tiny areas where multiple dangers overlap. The world looks calm from space. It is a sphere of blue and white, green and brown, turning slowly in the quiet darkness. From this great height, the Earth appears peaceful, a single interconnected system where clouds drift and seasons change in a gentle, predictable rhythm. This grand perspective can hide the intricate details, the small pockets of existence where the conditions are anything but gentle. Danger, we often imagine, is a vast and sweeping force, like a hurricane or a sprawling desert. But sometimes, the most profound lethality is not found across a wide expanse. It is concentrated, gathered into a remarkably small place. Imagine the surface of our planet overlaid with a fine grid, each square representing just one single kilometer. The overwhelming majority of these squares are safe, even welcoming. They contain our homes, our cities, our farms, and the wild spaces where life flourishes in abundance. People live and thrive within these countless squares, building communities and raising families. Yet, a very small number of these boxes hold a different truth. They are places where the fundamental forces of nature, or the consequences of our own actions, have created environments so hostile that they are incompatible with human life. One single step into such a square can end a life. This is not hyperbole. It is a statement of fact for a few precise locations on our planet. The danger here is not a distant threat or a gradual decline. It is immediate, overwhelming, and often absolute. In these 1-kilometer squares, multiple hazards can converge, amplifying one another and leaving no room for error, no time for escape. This essay will journey to these specific, deadly coordinates. We will explore why one small, seemingly insignificant square on the world map can be more lethal than an entire continent. The story is not one of drama, but of precision. The inquiry begins by zooming in. We leave behind the serene global view and descend rapidly toward the land. The continents resolve into countries, the countries into regions, and the regions into a landscape of hills, rivers, and forests. Our focus tightens further, until we are looking at a single, measured square. Within this boundary, the normal rules of survival are suspended. The air, the ground, or the life it holds has been altered in a way that makes it uniquely perilous. To comprehend the nature of these lethal zones, we must first dissect them. We can visualize this by using a simple micromap, a detailed view of our 1-kilometer square with its grid lines clearly visible. Upon this grid, we can overlay transparent layers, each representing a different type of hazard. One layer might show radiation, another might display extreme heat, a third could indicate the concentration of airborne toxins, and a fourth, the density of dangerous biological organisms. These layers reveal the story of the square. In most places on Earth, these overlays would be blank or show only low, manageable levels of risk. A person can navigate them safely, but in an extreme lethality zone, the icons are numerous and their colors deepen to red, signifying a threshold crossed into mortal danger. It is the convergence of these layers, the stacking of one peril on top of another within the same confined space, that creates the ultimate hazard. The dangers do not simply add up. They multiply. A single threat might be survivable with the right equipment, but 2 or 3 at once can overwhelm any defense. The concept of escape time becomes critical here. A hiker caught in a storm can seek shelter. A swimmer caught in a current can try to swim parallel to the shore. But within these specific 1-kilometer squares, the escape time can shrink to 0. The intensity of the hazard is so great that exposure for even a few moments is fatal. Or, the combination of dangers creates a trap. A path away from a radiation source might lead directly into a cloud of toxic gas, making escape impossible. This is why we must focus on facts, not speculation. For each site, we can create a zone card, a simple summary showing its name, its precise coordinates, its country, and a subtitle describing its primary threat. For example, a card might read, Chernobyl Exclusion Zone, Reactor 4 Core, followed by its latitude and longitude. Chernobyl, a ghost of invisible energy. At this scale, distance stops protecting you. The micromap for this location reveals a staggering concentration of radiation. Located in northern Ukraine, the site of the 1986 nuclear disaster remains a potent symbol of technological failure. The overlay shows gamma radiation levels that are not just high, they are immediately lethal. In certain hotspots, particularly in the ruins of the reactor building itself, and in the surrounding debris fields, an unprotected person would receive a fatal dose in mere minutes. The icons on our map would cluster in a deep dark red, indicating that the threshold for human survival has been crossed by an enormous margin. This is not a place where one can take a calculated risk. The risk is absolute. The ground itself is contaminated with radioactive isotopes like cesium-137 and strontium-90, which can be stirred up as dust and inhaled. This adds a second layer of peril internal contamination. So, a person here faces not only an external bombardment of gamma rays, but also the risk of breathing or ingesting radioactive particles that would continue to irradiate their body from within. Mitigation focuses on containment, not removal. The new safe confinement prevents releases, but it does not eliminate the danger within. Ilha da Queimada Grande, a living island of venom. At this scale, distance stops protecting you. Icons representing the golden lancehead scatter across the square until they almost merge into a single uniform field of red. Off the coast of Brazil, in the Atlantic Ocean, lies a small island known as Ilha da Queimada Grande. But its nickname tells a different story, Snake Island. The primary resident is the golden lancehead viper, a species found nowhere else. Estimates put at least one snake per square meter in some areas. The golden lancehead's venom is exceptionally potent, a fast-acting hemotoxin. It can cause kidney failure, it can cause tissue necrosis, it can cause cerebral hemorrhage. The island's terrain is rugged, with steep, rocky slopes and thick vegetation. That terrain provides perfect camouflage, making snakes nearly impossible to see until it's too late. Snakes are not only on the ground, but also in low-hanging branches, hunting the birds that make up their primary diet. Escape time is defined by the venom's speed and the island's isolation. The Brazilian government has banned public visits. Only a few vetted scientific researchers are permitted to land, and they do so with extreme caution, wearing protective gear and carrying anti-venom. For anyone else, this 1 kilometer square is a biological fortress. Darvaza gas crater, the Earth's fiery breath. At this scale, distance stops protecting you. The micromap for the Darvaza perimeter is dominated by two primary hazard layers: extreme heat and toxic gas. The crater itself, roughly 70 meters in diameter, is a roaring inferno. The heat radiating from it is immense, capable of scorching anything that gets too close. The ground at the crater's edge is unstable and can crumble without warning. The red icons for heat would form a perfect, lethal ring around the crater's mouth. But the danger is not just the visible fire, it is also the invisible air. The combustion is incomplete, releasing carbon dioxide and other toxic gases, with concentrations high near the crater, especially when the wind is low. This creates a second overlapping threat. A person might survive the radiant heat only to succumb to asphyxiation or poisoning from the fumes. The failure of mitigation here is a story of scale and persistence. The fire is too large and fed by too vast a reservoir of natural gas to be extinguished easily. Various plans have been proposed over the decades, but the technical challenges and costs are enormous. Unlike at Chernobyl, where the danger is contained, or on Snake Island, where it is confined by the sea, the danger here is an open, active process. The Earth is continually breathing fire and poison into this 1 kilometer square, making it a place where human presence is and will remain, fleeting and fraught with risk. What truly elevates a location from merely dangerous to one of the most lethal on Earth is the principle of overlapping peril. A single hazard, no matter how severe, can often be countered. One can wear a radiation suit, or carry anti-venom, or use a breathing apparatus. But when multiple distinct hazards occupy the same small space, the challenge becomes exponentially greater. The protective measures for one threat may be useless against another, or the presence of a second threat may render the first inescapable. Imagine a volcanically active area near a chemical plant that has fallen into disrepair. A tremor ruptures a corroded tank, releasing a toxic cloud, forcing a person toward unstable vents and superheated steam. The escape route from one danger leads directly into the heart of another. The time to think, to plan, and to act is reduced to nothing. In these extreme zones, the scale of movement changes dramatically. The familiar concepts of distance and safety. In our daily lives, a threat 100 meters away is usually no threat at all. But within our lethal 1 kilometer square, a few meters can be the difference between life and death. This precision is a key component of the danger. The boundary between a survivable area and a fatal one can be a sharp, unforgiving line drawn across the ground. There are paths that robotic vehicles have used where the radiation dose is manageable for a short time. But stray just a meter or two off that path, toward a fragment of discarded graphite from the reactor core, and the radiation level can spike 1,000-fold. A person might stand in a small clearing and see no snakes. But the space under the very next bush, less than a meter away, could conceal a coiled golden lancehead. The proximity is absolute. So why can't technology make this safe? Faced with such extreme environments, it is natural to place our faith in technology. We have developed incredible tools to protect us. Sophisticated radiation suits, advanced breathing systems, hardened robotic explorers. Drones can fly where people cannot walk. But even our most advanced technology has limits. In a zone of extreme radiation, the danger is not just to living tissue. High-energy particles can bombard and destroy sensitive electronics. The silicon heart of a robot's computer can be fried, its circuits shorted, its sensors blinded. Similarly, in a place of extreme heat like the Darvaza crater, materials we consider robust can fail. Metal can soften and warp. Polymers can melt. Lubricants can boil away. The complexity of overlapping hazards presents another challenge that technology struggles to solve. A suit designed to protect against chemical agents may be cumbersome and heavy, making it difficult to navigate unstable ground. A vehicle shielded against radiation may be too large to enter a confined space. There is often no single technological solution that can address all threats simultaneously. The environment becomes saturated with so many different types of peril that our systems are simply overwhelmed. They are designed for specific problems, but these places present a cascade of interconnected problems. This is not a failure of human ingenuity or will. It is a fundamental acknowledgement of physical reality. Technology can be a powerful shield, but every shield has a breaking point. In these 1 kilometer squares, the force being applied is greater than the shield's strength. This is why, even in the 21st century, some places remain effectively off limits. Their lethality, a stubborn fact that no amount of innovation can fully erase. As we conclude our journey, we zoom out. Grid lines of the micromap dissolve. The lethal square shrinks to a speck on the landscape. The region reappears. The country reappears. The continent reappears. The Earth resolves back into view. A blue and white marble suspended in space. Tiny points of extreme peril become invisible, absorbed into the whole. They haven't gone away, but their scale is put into perspective. They are exceptions, not the rule. This exploration was not to inspire fear, but to foster understanding. Danger is not always broad and amorphous. Sometimes it's highly concentrated, very specific conditions. The lethality of Chernobyl's core, Snake Island's ecosystem, Darvaza's fiery crater, is defined by confinement. Hazards packed so tightly their power is magnified, leaving no room for life to negotiate. The deadliest places on Earth aren't large, they're exact.